Good afternoon, everyone. Currently, we are going through what can be termed as a fourth industrial revolution or Industry 4, which is actually driven by technologies, advanced information and communication technologies such as artificial intelligence, building information modeling, big data, machine learning, blockchain technology, among others. While these technologies and their impact in the short run may vary, but they are here to stay and bring a deep impact on how businesses work and how projects are managed and executed. As said by Roy Amra, president of the Institute for Future, we tend to overestimate the effect of technology in the short run and underestimate its effect on the long run. On this note, I would like to start my presentation. The topic of my research work is development of a decentralized and automated contract management system for construction projects. I'll be covering the following contents in my presentation, starting right from background on construction industry to publications that are resulting out from this presentation. Construction industry accounts for around 13% of the global GDP. It forms an important part of the global economy. The global construction market is expected to grow over 4.2 trillion US dollars in the next 15 years, with almost half of it attributed to the Asia Pacific region. As per the Oxford Economics Report of 2023, India is said to be the third largest global market in construction and one of the fastest growing market globally. While construction sector holds such high significance, its contribution in India and worldwide, but the overall performance of the sector has been unsatisfactory over the years. It suffers with low productivity. The projects are generally behind schedule and over budget. There is complex market dynamics involving multitude of stakeholders and multi-level decision-making, which results in hefty claims and disputes. The average global value of construction disputes was 52.6 million US dollars, and the average length of dispute was 15.4 months in the year 2021, as per the Arcadis Global Construction Disputes Report. These reports also listed that the owner, contractor, subcontractor failing to understand and comply with contractual obligations and errors and omissions in the contract document were one of the leading causes in global construction disputes. Therefore, the industry must adapt to the changing landscape with more collaborative, faster, and transparent execution of construction contracts. Also, better contract drafting is not a panacea. What we are looking at is a transparent and effective implementation of the construction contract, which forms an integral criteria for a project's success. Therefore, this research is motivated to revamp and rewire the existing contract management practices. And a literature review of around 200 papers was conducted, out of which 175 papers are listed in the research thesis. The literature pertaining to construction contracts, contract management practices and challenges, dispute avoidance processes and practices, current information applications of information and communication technologies in the construction sector. An overview of certain papers was done in the areas of computer science on blockchain technology and smart contracts, and certain papers in the legal sector were studied based on the automation of construction contracts. Based on the literature review, the following research gaps were identified. The first and foremost gap was that despite a lot of progress being done in the construction industry with increased amount of automation and digitization, the contract management system continues to be traditional in its ways and quite conventional. There is low automation and digitization. While we can see automation and increased amount of digitization in project planning and building information modeling, but when it comes specifically to contractual practices, the ways are still traditional. There is, with increased amount of tools that industry is relying on, which are digital in nature, most of these tools operate in centralized architecture, which is hierarchy based. So there is security concerns for data tampering. These concerns are also seen by the industry when it looks at the automation of the contract management processes and practices, because again, the industry is skeptical that whether the security and transparency would be maintained. Most of the research is focused on dispute resolution mechanisms like artificial intelligence based dispute resolution systems, decision support systems. But when it comes to research on preemptive measures for preventing disputes from occurring itself, with increased amount of digitization and automation, we can actually prevent disputes at a very early stage before they become a full-blown dispute. Therefore, based on these research gap, the aim of the research and objectives were established. This research aims to develop a more collaborative, faster, and transparent contract management system that integrates the digital and communication technologies. In order to achieve this goal, the following research objectives were established. Total 5 research objectives are established in this research, and these research objectives we will be discussing in the coming slides one by one. The scope of the research is limited to construction contracts and their automation and construction projects and their implementation. Design science research methodology is adopted in this research. DSR goes with the philosophy of advancing innovative constructs such as conceptual models and proof of concepts to propose a scientific solution to a real-world problem. It involves multiple stages. There are total 5 stages in this methodology, and we have listed the methods and tools that were adopted to achieve them. The first stage is problem identification, which corresponds to the first objective as well, which is to identify the challenges which are there in the existing contract management system. So it was done based on literature review and informal discussions with the industry. Second is to establish rationale for integration of blockchain. So why am I using blockchain? What is the reason that blockchain is being integrated and proposed to be integrated in contract management processes and practices? This was done based on systematic literature review of 3 areas and attribute mapping. Then concept design and development. Conceptual models and for the proposed contract management system were developed. And implementation, this corresponds to the 4th and 5th objective of this research, where I have tried to implement the concepts by developing a prototype on an actual blockchain network. So a sample prototype of the contract management system is developed. And then communication and validation is the final stage of the research methodology, where the research is communicated to a set of industry experts and their feedback is received on the prototype as well as the entire concept. And second is that it is validated to a wider set of audience through publications and conference presentations. This is the overall research approach, overall schematic that presents for all 5 objectives and steps under each of the objectives that how the research is going to progress. Let us start with the first objective, that is to identify the challenges faced by the existing contract management processes and practices. These are some of the challenges that were listed based on the recent issues that are developing in the contract management processes. The process is long and tedious and onerous one. Then there is misaligned contractual structures, that is the incentives and structures of the contract are created based on the perceived needs of each of the party rather than the actual needs of the project. The progress which is recorded on field and the progress which is on paper, they vary. With increased amount of digital environment and increased amount of digital information that is being shared across the construction industry, there is a constant issue of ownership rights. If a digital or 3D model is available or an electronic document is available, then who owns the model, how much access which party has to the model, and if there are any errors or corrections that have happened in the model, then who is responsible for that? All these policies are unclear in the current contract management process. This leads to our second objective, where we are proposing that as a solution to all these challenges, not all of them, but most of them, blockchain technology is proposed as a possible and potential solution. So why is it proposed in this particular research project? So before starting with why blockchain, what is blockchain? Blockchain is, I'll give it just short overview due concerning time constraints, that blockchain is a technology that was used behind cryptocurrencies, that is Bitcoin and Ethereum and others. While in cryptocurrencies, it saw a huge impact, but it is being the blockchain data structure is being increasingly used in all other businesses and industries across the sectors. So it is a form of decentralized ledger technology. When we start with, there is a centralized sharing of records and there is a decentralized sharing of records where records are maintained where there is no central administrator or a middle person while sharing of records. It is something like Wikipedia, where when we look at Wikipedia or cloud data, there is access which is allowed to everybody for Wikipedia. But again, it is held centrally. If any damage or if the entire Wikipedia page goes down, all of the data goes down. But in case of a decentralized ledger, since the data is stored equally on multiple computers, even if there is tampering with one node or one computer, then also the data continues to stay and there is no discrepancy of data. Blockchain is a type of distributed ledger technology, which adds another layer to decentralization in terms of security and privacy, where data is stored in blocks as the transactions. The data and transactions are stored in blocks, and these blocks are linked to each other through cryptographic hash-based values, making the entire data secure and tamper-proof. Smart contracts are business logic for the automation and exchange of information on blockchain. So they are nothing but software codes which are like if-then operator, conditional operators or if-then statements, which help the blockchain exchange run. So we just look at a typical blockchain transaction mechanism. This mechanism is common across industries, but we'll take an example of construction industry. So say a particular contractor, subcontractor initiates a transaction. Transaction could be anything ranging from completion of a design document, completion of a amount of concreting work. So say a contractor has completed 500 cubic meters of work, then this transaction or this information is broadcasted to a network of stakeholders. These stakeholders must approve this transaction, and once they approve in consensus, then it gets recorded on blockchain and it gets chained on blockchain. And then the smart contract runs, which executes the payment. Like say 500 cubic meter of concrete is done, then this much amount of payment should be released. This whole data or whole chain of transactions or trail of records gets stored on the blockchain ledger, and it is available to all the stakeholders in real-time basis. This transaction mechanisms provides blockchain with 7 key attributes: that it is decentralized, near real-time, immutable, transparent and traceable, secure. In order to define why blockchain, we started with systematic literature review in 3 areas. That is causes of construction disputes, then dispute avoidance methods and the challenges faced by them, and then application and potential of blockchain in dispute prevention. Prisma search and screening strategy was used. So we have 3 reviews here. Now in the, as can be seen under the first review, we have used Scopus and Web of Science. In all these are the databases that are used, and these are the keyword search. So first review is for construction dispute and its causes. Second, dispute avoidance methods, and third one is for contract blockchain and contract management. After all the screening, total 109 articles were shortlisted, 35, 25, and 49 under each review. Then, as can be seen, the publication trends are like most of the papers are recent in last 5 years, although I had kept a range of 10 years, but most of the papers came in last 5 years. The analysis of the first review, as can be seen, that contract document and poor contract management and administration are some of the leading causes of construction disputes. And then we analyzed to come to the root cause of the dispute, which turned out to be certainty, everything condensed down to certainty, communication, and commitment. In the second review, we have tried to I tried to see what all are the recent methods and tools that the industry has adopted in prevention of disputes. And then what are the challenges faced by these tools in their successful implementation. And in the third review, the potential of blockchain technology and its applications in contract management processes was seen. These are the final outcomes from these 3 reviews. And then through attribute mapping, it was determined that these attributes of blockchain could help resolve some of these root causes of disputes in construction sector. So the 3C model was developed. This is basically stands on 3 pillars of certainty, commitment, and communication. Under this model, it is like there for any good contract agreement, it is essential that certainty of contract terms and their execution is there. There is commitment of the individual parties on following the contractual obligations, and communication among the parties plus communication of the contract terms. There is clear communication and meaning to the contract terms. On this note, I developed a conceptual model and execution framework comprising all stages of the contracting process. So this brings us to the third objective. So basically, the concept is that blockchain should be integrated to the traditional contracting process to develop a decentralized contract management model. Now, this is the conceptual model. This conceptual model has 2 key parts. One part is the automation of the construction contracts. Second part is deployment of the automated construction contract on the blockchain network. So first, from this contract agreement, a smart legal contract or an automated contract is created. Then this contract is deployed on a blockchain network of stakeholders. These are the contracting parties who are connected to each other in a decentralized manner, and they must approve in consensus and sign the contract on the network. So when the contract executes, all these parties are equally aware of where the contract agreement is currently, what is the contractual progress of the project, and also all the information gets recorded equally. So the contract could actually run in connection with Internet of Things and devices which are there on site. And then payment obligations and other obligations can be generated from the contract based on the execution of the contract terms. So this whole process makes this a digital, decentralized and automated contract management system. This is the blockchain-based execution framework that was developed. This is a framework where across 4, so I have shown a screenshot of only 2 stages because the other stages are there in a PDF document. So if it is required, it can be shared later on. And in this, I have created for 4 stages, that is tender stage, execution stage, and design stage, and operation and maintenance stage. Supply and operation and maintenance. So in the across these stages, as we can see, if we start with tender stage, then there is these are all the activities that are involved in the preparation of bid document, floating of tender, pre-bid meeting, award of contract, and there are parallel activities that run along with that, which would happen in case of a decentralized digital contract management system. Next, we look at the implementation of all these concepts. So this brings us to the 4th objective, which is to formulate and verify computable and automated smart contract clauses for construction contracts. So when I started and tried to make an automated construction contract, 2 things were required, because in any contract, any legal document, there are 2 parts. One is the denotational aspect, one is the operational aspect. So the operational aspect is something which is easy to code, where that it involves if-then statements or formulae, that if certain, say, price variation, delay, damages, so it could be calculated through formulae. But it is the denotational aspect that is a legal in terms and conditions which make it legally binding. So any code can run, but the code has to be a legally binding agreement for it to become a smart legal contract. These are the fundamental elements of the smart contract clauses or automated contract clauses that are tried to develop. So first is the legal text, which makes it human readable. Second is that I need the contract to be machine readable. So there is a data model which assigns values and classes to these variables. And third is that the contract must be self-executable or machine executable. So based on the conditions of the contract that we that have reached, the contract must execute on itself. So that is when the execution logic comes into picture. Now this is for the development of the smart legal contract. This is the execution model and development model that was created. So from the legal text, the smart clause template is formed. So data is extracted from the legal text into form of variables, logic, and data model. Now this becomes a smart clause template. This can be used across projects. This smart clause template I can use across projects. It's just like any predict contract clause. So it could be used across projects. But once the data is fed into this class template for variables. Variables would be like, what is the project value? What is the project duration? And say if there is upper cap limit of damages or anything, all these values can be fed, then it becomes a proper contract instance for that particular project. Once this contract instance is formed, it is deployed on the blockchain network. It has to be signed by multi-signatories, and then they must validate this contract based on digital signatures, and then it starts executing on the blockchain network. So I tried to create automated contract clauses for two contract clauses. One was delay damages or liquidated damages. This is based on a paper developed by Tripathi et al. Earlier under Professor Jha only. And he created a formula for calculation of delay damages. So this formula was only developed into it was automated. So this is the template development. As can be seen in the template development, this part is the template where these are the variables for for the contract. Then second is the contract data. Now these variables are assigned value during the contract data, and the data model is attached to these values. And then this is the logic for execution of the contract. Now the request is to be input at each time when the contract is getting executed, that how much delay has occurred if for a delay damages clause. So this is the total delay, and this is the delay attributable to the contractor. This is the timestamp, like on what date and time the work has happened. And accordingly in the response, it calculates the levy of compensation and the percentage of levy. And where the contractor delay is really low, it gives an error stating that employer is not liable to delay damages because delay attributable to employer is very high as compared to the contractor. So these are the outputs that came. And then second clause that I attempted to make a smart automated contract clause was adjustment for changes in cost or price variation clause. In this also, again, this is based on the FIDIC price variation clause. And these are the project specific parameters. So here we input data at two places. One, when the contract is being formed, and second, when the contract is getting executed and some delay has actually occurred. What is proposed is a integration of smart contracts into Internet of Things and all these baseline scheduled project records and payment execution methods to develop the smart legal contracts and deploy it on the blockchain network. This is the overall bigger picture. That is where FIDIC contract clauses of time, delay, extension, and price variation, they are connected to each other. And the overall execution logic is defined that, say, these contracts don't run individually. So if a delay has happened, then automatically price variation clause comes into picture or extension of time comes into picture. So how they are connected to each other and what are the requirements, they are shown here in this particular flowchart, where all the white boxes are the one which the smart legal contract or automated contract would execute on itself. And these are the responsibilities that are for the contractor, employer, and engineer. So this finishes the fourth objective, where I've tried to create an automated contract clause. Now comes the fifth objective, that is development of a prototype model of blockchain network, where this contract clause or this contract is to be uploaded on the blockchain network. And for that, first thing was to select the tool which is best for creating the blockchain network. So it was list of blockchain platforms were identified, and these blockchain platforms were mapped against the requirements specific to construction sector, and accordingly suitable blockchain platform was determined. These are the blockchain platforms that were identified, and they across their different attributes. These are the requirements of the construction sector. The first and foremost requirement was that the platform should be permission. Not everybody should be able to join the network. Only the contracting parties should be able to join. And these are other requirements. Based on this, Hyperledger Fabric Linux was the tool that was identified for the development of the conceptual blockchain network. The project that is considered is Dedicated Freight Corridors of India. This is the project that was considered for development of the network. These are the different stakeholders and the project structure involved. It's a mega project, so the number of stakeholders are huge. So this is Ministry of Railways, DFCCIL engineer. They enter into one contract agreement. The second contract agreement is between contractor, designer, subcontractor, and supplier. And there is a third contract agreement, which is between in Ministry of Railways, DFCCIL, and financial consortia, that is World Bank and JICA. The RASI matrix was prepared because if I create a blockchain network of stakeholders, it is essential to understand what are the roles and responsibilities of each of the member on the network. Therefore, a RASI matrix was developed, which is responsible, accountable, consulted, and informed. These are the for each of the practices in the tender document. What in the entire contract document, what are the responsibilities of each of the parties? They were defined. Based on this RASI matrix, the roles and access controls of the stakeholders on the blockchain network was defined. And this is the conceptual blockchain network. So as it was shown earlier that 3 sub-networks are formed within the network because there were 3 contracts. So one is between the main contractor and subcontractor, designer and supplier. There is another sub-network or contract between the employer, the main contractor, and the consultant. And there is another third subcontract, which is between contract or sub-network, which is between the Ministry of Railways, the employer, and the financial consortia. Now, since that was a conceptual blockchain network, this had to be developed on the blockchain platform. So these are the tools that were used to develop the actual blockchain platform, starting from Accord project templates that were used for creation of smart legal contracts, then Visual Studio Code that was used for development, packaging of the smart legal contract and testing of the contract code. Then IBM Blockchain Kubernetes Service and cloud-based platform for actually development of the blockchain network. And third is IBM VS Code extension. IBM was one of the platforms that was used. I started with it in 2021, but recently new platforms have come into picture based on AWS, that is Amazon Web Services, which can also be explored because IBM proved to be quite expensive as a platform. So 12 steps were involved in development of the prototype model. The first step was creation of the smart legal contract. And this is the code logic. Then second was testing and packaging the smart contract. Third was creation of the Kubernetes cluster on IBM Cloud and launching the IBM blockchain platform. Then this fifth step was creation of the decentralized blockchain network. So as can be seen, 7 stakeholders are there, which were part of the DFCCIL, key stakeholders, contractor, employer, engineer, financial consortium, and all. They are added on the decentralized blockchain network. These are the peers. So all of these organizations have one member or few members who will be a part of the actual network. So that was the set of organizations, and these are the members from the organizations who will be joining the network. So roles and responsibilities of these members were defined on the network, whether when a transaction is proposed on the network. So not everybody has to approve of it. How many people must be approving, and whether it should be majority or whether there is a compulsion from one party. Those all are defined. Then sub-networks are created. So here, as can be seen, for channel 1, engineer, employer, and contractor was one sub-network. So like that, different channels were created in the main network. Then access controls of organizations. So not all peers and organizations may have the requirement of operator or administrator controls. So there were controls where the organizations will only be aware of what is happening on the network, but may not be able to write or operate the network. Then smart contract, which was created earlier, automated contract, it was deployed on this blockchain network, instantiated, and then the any transaction that is to be happening. So this is the proposal. So say a signature request is submitted, then based on digital signatures, the request is received, and we have timestamp of everything, that when the signature request was submitted and when was it received. These are the block cutting parameters of the blockchain ledger. These basically decide the costing of the project, because the storage, the transactions that have been stored per block are can be monitored here. The final part of the research was validation of the research, because this is a novel technology and it is not yet mainstream adoption is not there for this technology in construction sector specifically. Therefore, it was essential to validate the research. And the research validation was done in two ways. One was case study method, where 3 construction project case studies were considered. And this application of smart legal contracts was seen in these 3 case studies. And then the second was feedback from industry experts. So these are the 3 case studies. The first case study is of new technology center building. In this case study, we tried to check the liquidated damages clause. That is the first contract clause which was created. This was checked in this case study, and the responses were in line with the original response calculations. Then second case study was of dedicated freight corridors itself. Here, price variation clause was developed and modified as per the requirements of the contract. And again, it was tested and checked. Then in the third case study, we checked what is the use of these smart legal contracts when it comes to dispute prevention and avoidance. So in this case study, we had taken the case of a dispute between a contractor and an employer. And through decentralized smart legal contracts, it was determined how this all of these claims can be prevented, or these disputes can be prevented before occurring. So there was one of the disputes on the whether the contractor's claim is time barred. That is, whether the claim that is made by the contractor is within the time limit in which the contractor had to claim. So as per pretty conditions of contract, the claim is to initiate it within 28 days. So if it gets automated, then the contractor, there is no dispute on this particular issue, because the smart legal contract will not take the claim if the date is crossed. So it gets automated. So the whole requirement of dispute is prevented. Similarly, for total 4 issues, it was determined that how smart legal contracts can be used for prevention of disputes. In the second part, validation from industry experts was taken. So around total 10 industry experts were considered. It was ensured that these industry experts are from 3 different areas, that is client, contractor, and consultant side, to make their response holistic in nature, that we have all 3 reviews from all 3 sides. And a questionnaire survey form was floated. It is a 4-page questionnaire survey. The questionnaire survey basically was designed for 2 key purposes. One is to understand the industry perspectives. That is, how much industry is ready for adoption, what are the challenges they actually face, and what is in their opinion, the potential of blockchain technology in construction sector. Second part of the survey was to determine the potential, we requested them to rate the prototype that was developed on all these areas, that is transparency, security, automation, and real time. And Likert scale was used from strongly disagree to strongly agree, 1 to 5. And as can be seen, the mean values are between 4 to 5. So most of the industry experts were positive about it, although they had their own reservations towards automating the contract management processes and practices. But they felt that if we it is a good step towards a new beginning and a new way approach to things. These are some of the written feedbacks that were received from the industry experts. All of them are not listed. Few of them I have listed here, which we have received in terms of responses from the industry experts on the model which was demonstrated to them. So one of the experts mentioned that the work is a niche area and will evolve over time, and therefore any beginning in the right earnest is welcome. The second said that the work is highly aligned with present day requirements. There were certain concerns of the industry experts that the code could be, what happens if the code is malfunctions, what happens if there is erroneous code, and even if, however, we use blockchain and think it's watertight, but what happens if somebody actually manages to hack the contract? So cybersecurity concerns were raised. Also, there were concerns on scalability, because construction projects are massive and the storage on blockchain scalability could be a big issue. and legal inflexibility in terms that if everything is automated, then the flexible part of the contract is lost. So in summary and conclusion, this research was mainly focused on two parts. That is, one is automation of the smart legal contract or code contracts themselves, and second is decentralized execution of those contracts. So under 5 objectives, we tried to conclude the research, and these objectives were achieved, and these are the challenges that are to the existing contract management system, and it was identified that through a decentralized contracting system, a lot of these challenges could be addressed. The scientific and practical implications and contributions of the research are as follows. That first, this is one of the first research that explores blockchain technology in improving trust and transparency in contract management system. The systematic literature reviews that were conducted, they could be really helpful for people in industry and academia because it gives a holistic approach towards construction disputes, where we look into the root causes of disputes, their sources of disputes, and also the dispute prevention methods that are there. Then the conceptual model and execution framework could be a basis for further research in digital contracting. The smart legal contracts that are created, they are pioneering examples. These are one of the first in construction industry where we look at automation of a construction contract is attempted. The study is not so. Most of the studies in blockchain applications are conceptual in nature, and this study goes into and shows the implementation part of the concepts that were built, and that is why these are some of the contributions from this study. Also, it provides a novel perspective to the researchers in terms that research can also be focused on prevention of disputes through increased amount of applications of information and communication technology rather than looking at resolution of those disputes later. The research, despite its contributions, has limitations and challenges of its own. First is definitely the literature review constraints, because I've considered only 2 databases, that is Scopus and Web of Science. And the literature that is considered is mostly of English papers of last 10 years. So these are some of the constraints, like I might have missed out some papers in the database. Scope limitations were there, of course, and discrepancies if code malfunctions or code outcomes change, then those are some of the limitations. Technology challenges like scalability, interoperability of this proposed system involves multiple systems under it. So the interoperability issues between each of these systems with each other, extracting data from a construction schedule, and all these issues would be some of the limitations in this research. And the prototype that is developed is generic in nature. It is a small scale development. It is not analyzed for cost. So it is a good scientific solution, but whether it is an optimal one that cannot be assured unless the cost benefit analysis for the prototype is done. So this is also one part which is not considered. There are regulatory concerns, like if, say, a dispute arises between parties for a smart legal contract, then who would be the judge, under which judiciary it would be considered. And all these are certain regulatory constraints to the application of this system. Based on these limitations, we get future research. Some of the future research scope ideas were given by the industry experts themselves, and they were quite keen on these ideas. Like one of the experts suggested including artificial intelligence-based decision-making into the process, where the decision-making itself can be refined with increased use of artificial intelligence plugins. Then inclusion of dispute resolution mechanisms, because if some dispute occurs, then the whole system can exit and go to a separate dispute resolution mechanism. Then one more is that optimizing the system, which is not economically viable right now. This was the coursework that was completed as a part of my PhD research work. And these are the publications that have resulted from the research. So first 3 publications are published, and the 4th one is under second review. So for each of the objectives, these are the publications that I've achieved based on this research work. And this is Institute Journal, which was published in Hindi in Jigyasa. So, and then these are the 4 international conference publications that have resulted. Thank you. I would like to extend thanks for my supervisor, Professor K.N. Jha, for his unwavering support and guidance throughout my PhD journey, and all my lab colleagues, without whom I would not be standing here. Thank you very much.
Thank you.